So have you come up with any kind of anything yet? Let's talk about this from a picture standpoint. If we're approaching 1, here's 1, and our limits are infinity and negative infinity, what's happening at 1? I have a vertical asymptote. And as I'm coming in from the left, I'm going down. I mean, I have no idea, but it's doing something like that. And as I'm coming in from the right, it's going up. Would you agree with that? Okay, so if I have a vertical asymptote at 1, then what do I know about my equation? I have x minus 1 in the bottom. Whatever else is going on, I have x minus 1 in the bottom. Everybody with me? Okay, now let's look up here. Something is happening. This says as I come toward 3 from the left, so here's 3 in my picture, the limit's 5. So would you agree, and it's from both sides, would you agree that the 0.35 is in the picture? The closer x gets to 3, the closer y gets to 5. So if I'm 3, then they're coming at 5. They're coming together at 5. Now, I really can't tell from the given, let me read my directions one more time. I really can't tell from the given if that's a hole or just a point on the curve, because it could be either one. So I'm going to make it a hole. If that's a hole, then what do I know about my equation? I don't need another x minus 1. I need an x minus 3. And I need it in the top and the bottom. Would you agree with that? Now there's one more thing I need to think about. And that is, if this were my function, if that were my function, we would immediately cancel that out, right? And have 1 over x minus 1, because that's how I would get a hole there. But what has to happen when I go back to find the hole and I plug in 3, what has to happen? It has to equal 5. And right now, when I plug in 3, it equals 1/2. So how could I fix that? What could I do? What would happen if I put a 10 right here? Instead of having a 1 be that coefficient, what if it was a 10? Would that work?
Yeah.
So I just have to think about, what does that leading coefficient, or whatever you want to call it, that number right there, what does that have to be to make it work for me? Now there's one more thing I need to check, and this is what I want you to do on your calculator. I want you to go ahead and sketch this equation right here. Go ahead and put that into your calculator. Because what am I checking? I'm checking to make sure that this is what's happening. Because if it's not, then I have to do something else to my equation.
I left my calculator in here last class. Have you by chance seen it?
No, but he said the same thing. No, I haven't found it. And when that happens, you need to alert me immediately. Because, no, I nobody turned it in and I didn't see it, so I don't know. Okay, so, when you graph that, what does that look like? Does it have the right shape? 1 or 10 divided by x minus 1. Yeah, it's going down on this side and up on this side. Any ideas what we would do? What if it was backwards? What if it was going up on this side and down on this side? When I graphed it, the picture is the picture. But what if when I graphed my equation it was backwards? Any thought on how I could fix that?
Make it x plus 1.
Oh no, making it x plus 1 would do what? That would change the asymptote, and I don't want to do that. I want to change the direction of the curve. How do we change the direction? We throw in a negative. Yeah, just make it negative. But it turns out we don't need to. This would be perfect. Okay? All right. Now that I've done that one, would you try B? Try B. Take a minute and remember how we built that, guys. First thing we did was kind of look at a picture. Then we put in our asymptote, put in our hole, and then made whatever adjustments were necessary. Tell me what you know. What does this tell me right here? When I'm approaching -1, here's -1 right here. When I'm approaching -1 and going up and or down, that means that's an asymptote, doesn't it? But this is a little interesting because on both sides it's going up. That's okay. Alright, it's a little interesting. So what does this tell me? I'm going to have a hole at -2, comma 4. So what does that tell me about my equation? I'm writing a rational function. What's in my denominator? X plus 1, that's gonna stay. That's not going anywhere. That's gonna stay. What's in my numerator and my denominator? X plus 2. Which, obviously, if I'm graphing, that's gonna cancel out, and I'm gonna be left with this, right? Now, I want you to graph that on your calculator. We haven't made any adjustments yet, but I just want you to get a general sense of that shape. You probably already know, but go ahead and sketch it and tell me what's wrong with it. Oh shoot. That's not going to be a copyright infringement, is it? Certainly that song is not copyrighted. Oh God, if I'm not here tomorrow, you know where I am. YouTube jail. that story, I told you that story, right? Oh, yeah, so I'm videoing like always, you know, and the bells are all wacky. The music comes on in the middle of it, I don't think anything of it, I wait for it to, and you know how sometimes the music's off and it just comes on? So I didn't think anything about it. Waited till it was over, went ahead, posted the video, get this note from YouTube that I am a copyright violator, and that video has been automatically deleted from YouTube because of my infringement. I'm like, oh, okay. Well, then, like 6 months went by, and it happened again, and I didn't even think about it. I should have, I didn't think about it. So then I got like an official letter on like legal letterhead that I'm now a 2-time offender, and that's what they called me, 2-time offender. And should it happen again, there will be legal action, and I'll be banned for life from YouTube. So now I'm like panicking every time there's any kind of, I mean, look at me, seriously, a YouTube offender, I mean, oh my God. But whatever. Okay. Anyhow, what's that look like? What's wrong with that?
The left is coming down.
Yeah, it's not going in the right direction. Now, I know that last time, you know, we're gonna make an adjustment, because we need this to happen, right? We need to get a 4 out, but that is not going to fix this problem. Because even if I put a negative in there, whatever number I come up with, that isn't gonna fix it, because all that's gonna do is make the other side positive and the other side negative, right? So who's got an idea about what I could do to make both sides go up? Basically, I have to make both sides be positive. Any thought on how I could do that?
Make it square.
Yes. Try this on your calculator, guys. Sketch that. Now, does squaring that change the asymptote? No. No. So fundamentally, it's still the same. But what happened now to your picture? Did it do what you wanted? Did it go up and up? Okay, so now we've got the right shape. So now all we need to do is make it so that if we plug in -2, we get 4, right? So let's see, what do we get right now? If we put in -2, we get 1, don't we? So what do you suggest? Put a 4 up there. So this would be my equation that accommodates, remember, because this part's gonna cancel. So I'm gonna end up, if I put in -2, I'm gonna get 4. I'm gonna have both sides rising on that asymptote. I'm all good. That's a little tricky. But I think now we've talked about all the big pieces of it.
So can you just write the simplified version as 4 over x plus 1
No.
squared?
Because then you wouldn't have the whole. You see what I'm saying? So again, I'm assuming that this problem, because it's in this section, that point right there is a whole. There really is no guarantee that that would have to be an open dot, that could be a closed dot, but I think to be safe, I'm gonna go ahead and assume it's a whole, and I'm gonna write down the whole thing. If I only wrote this, there would be a hole. Would you agree with me?
Yes.
Yeah.
So when we graph it, we do the bottom.
Yeah, yeah. I mean, you can graph this one if you want, but since those cancel, they're just gonna come out of the problem anyway, so why waste the time typing it in? Okay, perfect. All right, example 4. Sketch a picture of the rational function that has these properties. Okay, so basically same thing, only all we're doing is drawing a picture. Okay, all right. All right, so f of x has a hole at 1. All right, so somewhere over here, there's a hole. Does it give us any more information than that? As x approaches 4 from the left, f of x increases without bound. What does that mean? vertical asymptote at 4. Very good, Patrick. Vertical asymptote at 4. And as we approach from the left, it's increasing without bound. Okay, I gotta deal with this in a second, but let's see what else happens. As x approaches 4 from the right, it decreases without bound. And there's a hole at 1. No. There's a hole at 1. Do I know where my horizontal asymptote is? No, I just went ahead and stuck it in at 0, but you could put it somewhere else. As long as you've got this action going on here, and this, you're all good. Is that okay with everybody? Easy enough. All right, now we have 2 holes. All right, so where's my asymptote this time? As x approaches -1 from the left, we're decreasing. And from the right, we're also decreasing. As x approaches from -1 from the left, it decreases. As x approaches from the right, it also decreases. Is that okay with everybody? And I have no idea again what's going on with my horizontal asymptote, but I have to have a hole at -2. There's a hole at -2. And I have to have another hole at 3. So I can go ahead and put my asymptote there again if I want. And there's my picture. From what we just talked about a minute ago, what would that behavior suggest about the equation? That there's a squared on that factor, because that would make them both go the same direction. And somewhere in there, there's a negative to make them both go down. So instead of like having the 4 on top like we had before, we have like a -4 up there to make them both go down. Very, very good. Okay, turn the page. Let's go to the back of this. It says the whole truth. Go to the back of that. So this is like review. We already know this stuff, but here we go. So f of x is x squared minus 16 over x squared plus 3x minus 4. So what's the very first thing you're gonna do? It looks like we're gonna answer a bunch of questions and then graph it. Okay? So what's the first thing we're gonna do with this guy? Factor it, sure. So x plus x minus. X plus x minus. I haven't done this already. This looks so familiar. Alright. Zeros, y-intercept, vertical asymptotes, holes, horizontal asymptote. Okay. Here we go. Tell me what you know. From the factoring there, what do we know? We're gonna have a hole at -4. That's exactly right. Now, we do have to write that as an ordered pair. So it's going to be -4 comma something. Does everybody get, we have a hole at -4? And then how are we gonna find the something? Plug it in here, so that's gonna be -8, 8/5. So I'm just gonna go ahead right now and put that in my picture. -4, 8/5. Perfect. Okay, what else can I tell about my curve? Well, I need to know zeros, y-intercept, vertical asymptotes, and horizontal asymptote.
Zeros are 4 and
The zero, be careful, the zero is just 4. Remember, this is where the stuff is coming from for the picture. You can't have a 0 at -4 because you have a hole at -4. X can't be a -4. But I do have a 0 at +4. A 0 is just another word for x-intercept, right? Okay, what else? Vertical asymptote at x equals 1. Make sure that you always write your asymptotes as equations. So x equals y equals. Okay. How about y-intercept? What's my y-intercept? 4. How do we get a y-intercept? We let x be 0. So 4. And how about a horizontal asymptote? Well, it is 1, y equals 1. How do we find, these are called end behavior asymptotes. How do we find them? We look at the highest power in the problem, and if they match, bingo, that's a winner. X over x, that's y equals 1. Can you sketch the picture? That's everything. And now number 2 says, evaluate to determine whether f is going to positive or negative infinity. You don't need to because you got it right here. What's happening in this quadrant? You got points in this quadrant. What's happening here? Isn't it doing that? You don't need any other points. You could certainly find extra points, but you've already got them. You got this one. What's happening in this quadrant? Yeah. There's your picture. Perfect. Wasn't that easy?
Yeah.
Okay. So now you're going to do, if you turn the page, there's just some more of that kind of stuff. So we're going to do number 1. I want you and your partner to do number 1. See if you can find all the information they want you to find, and then ultimately sketch the graph. Just like we just did. Is this one going to have any holes in it? No. Is it gonna have any asymptotes? It's gonna have a vertical at 1/3. Positive 1/3?
Yep.
Everybody okay with that? Positive 1/3? How about a horizontal? 2/3? Remember, you gotta match. That's the best case scenario in the whole wide world. We love our matches, so 2/3. Does it have a y-intercept? The origin, 0, 0, which by the way is also the 0 or the x-intercept. Okay, now I want you to stop right here. No one should be at all confused. That point is the only place that you can touch an axis in this problem. Okay, so whatever you draw, it can't touch an axis. So think about this for a second. Can you envision the shape that we must have here for this? If we have to approach our asymptotes and we can't cross an axis, except there, doesn't it have to look like this? And like this? Think about that for a second. Could it do anything else? Remember, as it goes to the left, it must get closer to this asymptote. That's an end behavior asymptote. So its choices are, it comes in from the bottom or it comes in from the top, that's all it can do. It can't come in from the top though, because it also has to approach this asymptote as it goes up, and if it did that, it would cross the axis and can't. Do you see what I'm saying? You can usually, without plotting extra points, figure out what's going on. Jacob?
How do we know if it, like, I know it usually follows it, but how do we know if it goes through it and comes back, follows the, horizontal?
Oh, you mean, how do I know that that's not like a kind of weird point where it zips back up?
Yeah,
Okay, well, there would be something in the equation to clue me in on that, but if you're really concerned about it, you're gonna try a point in there.
yeah,
And it would have to be, what is that, 1/3, it'd have to be something like 1/6 or something. And if you put 1/6 into your equation, real easy to check, the top's gonna be positive, but the bottom's gonna be negative. So when I put that in, it goes down. So, yes, there's nothing in the problem. Remember how we put a square in there before?
Yeah.
And that kind of changed things up? There's nothing in the problem that would indicate that to me, but if you are concerned, then that's how you check. You pick a point and plot it.
How would you write the limit?
Okay, we're getting ready to do that, okay? So are we good with the picture? Because now we gotta go back and fill in all the rest of the answers that I skipped. So find all the vertical asymptotes and describe the function behavior around them. So my vertical asymptote is at 1/3. So my behavior is going to be expressed like this, limit notation around my vertical asymptote. Everybody okay with that? Now, having already drawn the picture, I know exactly what's happening. As I approach my asymptote from the left, negative infinity. Remember, vertical asymptotes, their limit as x approaches a vertical asymptote is always going to be positive infinity or negative infinity, because you have to veer, go up or down. Okay? And then, how about from the other side, from the right side, it is positive. Okay, Raina, so that's that asymptote. The direction said, describe the function behavior. This is the description. What happens to the curve? Well, on this side it goes down, and on this side it goes up. Okay? Number 2, evaluate the limits. The end behavior. You can tell from your picture what is happening on the right side of the picture. As I go all the way to the right, what's happening? Closer to 2/3 of the top. And on the other side, going left, I'm getting still closer to 2/3. Always, I'll be getting closer to my horizontal asymptote. I have one. And that one's from the bottom. Found all the intercepts and graphed it. Good? All right, let's do one more here, number 2. And then we're gonna do something even more fun than this. All right, so number 2, here's your equation. I want you to do every part, but not necessarily in the order they are. So for example, I graphed it first and then went back and filled in my other information. Do whatever you want to do, but let's see if you can get everything answered. from you. If there's something that's confusing you, if you're stumped on something, we need to talk about it.
The y-intercept.
Don't have a y-intercept. Why can't we have a y-intercept? Because x cannot be 0, which is perfectly okay. It just means you're not gonna ever touch the y-axis, right? So whatever it looks like, it's not going to touch the y-axis because x cannot be 0 in this problem. So I don't have a y-intercept and I don't have any holes. Would you agree with that? That happens. It's okay. Did you get an x-intercept at 1 or a 0 at 1? If you plug in 1, you get 0. That's your x-intercept, right? Okay with that? So really, this time, that was the only point I had to go on. Did you get a horizontal asymptote at -1 because of negative x over x? Did you have any trouble drawing the picture? Did the picture make sense to you? Keeping in mind that as you go off the page in all directions, you're going to get closer to your asymptote. Okay? So as I go this way, I have to be getting closer to this line. As I go this way, I have to be getting closer to this line. That's what asymptotes mean. It describes your behavior as you head off the page. We good with that?
You just know which quadrants it's in by the limit notation? Like the,
No, I knew which quadrant because it's gotta contain the points I plot. So when I start plotting my holes and my intercepts, like that's the only point I have, but that tells me, okay, the curve has to go through that point. So it can't be down here, because we can't go through that point down there. So it's up here, and then over here, there are no points on this side, but the only shape that's possible would be this, up here, and I can't do that. It has to be down here, because it can't touch an axis. Does that make sense to you?
well, you said it couldn't be up on the top left one because there's a
It
hole.
would have to, no, it would have to cross here. And do I have a
Cross
0
axis.
there? Mm-mm, this is the only place it can cross. Okay, so it's a big deal. I mean, always when we graph, get those intercepts in there. And then keep in mind that that's it. You're not crossing an axis anywhere but in those, at those intercepts.
And how do you know it's not in the farm, like,
Down here, it has to contain that point. So what would it look like if it were down here and had to contain that point? If it went up, it has to approach this asymptote as it goes off the page. I suppose it could come up and then bounce off and do something weird like that. There is nothing in that equation that suggests that. But Julie, I'm gonna tell you the same thing I told somebody a minute ago. If you have a question about it, then you're going to plot a point. You're just gonna have to do that, okay? I'm old and I get that, and I've done zillions of these, but there is no squaring going on in this problem. There is absolutely nothing weird about this problem at all. So I would expect no strange behavior. But if I'm worried about it, I got a test grade writing on it, I'm just gonna plot some points. So 1 point would do it for you. Put in a half. Julia, put in a half. If I put in a half, my top is gonna be positive and my bottom's gonna be positive. So that tells me that a half is positive. Now I have no choice. It has to look like that. Okay? So anytime that you are at all confused, you're going to do a point. As many as it takes, usually 1 is all you need to check. Okay? All right? Now, I want you to go to the 5th problem here. There's several in this case. The 5th problem. And I'm actually going to make the 5th and 6th problems homeworks. But the other class, yesterday, we got a little further than I got with you the day before, and we did those 5 and 6, so we're gonna do them right now. Together with your partner, I want you to work on 5 and 6, and then, we'll kind of check them, see how you did, and then give you a homework grade for that. So make sure that you are answering all of the questions. In any order. Okay, did you get the first one done? What do you think? I hope you're not overthinking it. After you do your canceling, what shape are you gonna have? It's just a line. Now, the line does have a hole in it. Did you put the hole in it down here? You obviously have a y-intercept and an x-intercept. Okay, so your limit behavior toward your function behavior at your hole is, since it's a hole, it's just -7. Both sides are coming into -7. And then your end behavior is just what your line's doing. So positive is going positive and negative is going negative. Is everybody okay with that? any question about that, do not make it hard. This is what we mean when it says describe the function behavior. This is what your picture is doing.
So if there's not like a vertical asymptote, it's the whole for the, like.
It's any vertical asymptote or any hole. So if you had both, it's gonna be both, which I think is what's gonna happen in this problem. Right, we have to describe the behavior, function behavior at all holes and asymptotes. Alright, so you get number 1 done, or number 5 done? Good for number 5? Alright, let's move on, we got 9 minutes, we gotta get number 6 done, let's go. Make sure you answer all the parts of the question.
Oh. Did you get a hole in this one? Was it at 5, 7/12? Okay. Automatically then, you're describing your function behavior. The limit as x approaches 5 is going to be 7/12. That's where it's going, to 7/12. Your limit behavior is always gonna be your y value if it's a hole. Did you have a vertical asymptote at -1? X equals -1? Yep.
So I'm gonna have to describe this behavior here. I'm kind of waiting until I get my picture drawn. But I have to describe what happens as I approach the asymptote from both sides, right? Did you have a horizontal asymptote at 1/2? Okay, so that means that my end behavior is going to be 1/2. Now I'll have to figure out whether it's 1/2 from the top or bottom. But would you agree that that's gonna be my end behavior, since that's my horizontal asymptote? Keep in mind the whole is at 7/12, which is bigger than a half, so it's on top of the asymptote. Did you get 0, 1 as your y-intercept? And -2, 0 as your x-intercept? Okay, now you've got everything. If you got all that, then you are ready to sketch this graph. Everything you need is here. What is your thought about this side, the left side of the asymptote? What's your thought? Are you seeing this? If you're not, then you're gonna pick a point, right? Just remember that the curve has to contain that point, and it has to get closer to this asymptote and this asymptote. Now, what about over here? What's happening on the right side of my picture? Are you seeing this? Again, any confusion, you're gonna plot a couple of points, whatever you need. And now I can fill in these. So on the left, I'm approaching my horizontal asymptote from the bottom. On the right, it's from the top. On the left, my vertical is going down, and on the right, it's going up. So now I have answered all of the questions. Okay, did everybody do that? I'm gonna give everybody 5 out of 5 for that, if you all did it. Everybody did it? Everybody got it? Okay. Alright, I'm assigning the 1, 9, 1, 10 homework then. And what is today? It is Monday. Your 1, 9, 1, 10 homework is gonna be due on Monday. Okay, and then I have a, oh, sorry, little